Welcome back to another installment on linear inequalities and graphs. Now, if you're new to my channel and you've not watched any of my videos uh, under the inequalities playlist, then I'll show you how to do problems on inequalities. If you have seen my videos under the inequalities playlist, then consider this a refresher or a good practice, right? So let's get started. So these are two separate problems, by the way, they're not related in any ways. So here's how you do the first problem. So you have 7 minus 2x greater than 15. For those of you that are first watching my videos for the first time or learning the inequality concept for the first time, you want to retain your x on one side and you want your numbers to be on the other side. Since my x is currently appearing on the left-hand side, I prefer to keep it there, right? So the way I can get rid of the 7 is to subtract 7 on both sides, which would make it negative 2x greater than 8, right? X is, I can divide by 2 on both sides, which is negative x greater than 4. Now, your x cannot have a negative value attached to it. So the way you can get rid of the negative is to either multiply or divide by negative. They both mean the same. When you do that, you are going to reverse the sign of the inequality. So x is less than or equal to negative 4. I just divided or multiplied. You can divide or multiply by negative, okay? That's what I did in this step throughout the expression, and I got x less than negative 4. Here's how you solve the second problem. 10 plus 3x greater than negative 11. So I can subtract negative 10 on both sides. So negative plus 3x is greater than negative 21. X is greater than negative 7. I just divided by 3 on both sides, okay? Now, contrary to the x, if the number has a negative value, you don't need to take any action once you simplify the expression, right? So you can just leave it as it is. Here's how you do inequality expressions containing an absolute value. You have an absolute of 2x minus 3 less than or equal to 2. You can split the problem into two parts, a positive domain and a negative domain. You may not hear this explanation in other videos. This is the way I understood it, and it seemed much easier, so I'm showing it to you, okay? If you have a difference of opinion and you have a different way of solving it, please let me know in the comments box below, right? And this is much easier the way I'm showing it to you. For the positive, you retain the value within the absolute sign as it is. So 2x minus 3 less than 7. You can add plus 3 on both sides, which would give you 2x less than 10. So divide by 2 on both sides will divide by 2 on both sides will give you x less than 5, right? Similarly, for the negative domain, just add a negative sign and 2x minus 3 less than 7. You have to get rid of the negative, so you can divide or multiply by a negative sign on both sides. When you do that, you have to flip the sign of the inequality to negative 7. Inequality from less than equal to greater than equal to. Now add plus 3 on both sides, so 2x is greater than negative 4. Divide by 2, which would give you x greater than or equal to negative 2. In other words, negative 2, x is greater than or equal to negative 2 and is less than or equal to 5 is the collective expression for this inequality. Okay? Now that you see me do this first problem, I highly recommend you pause the video and try to solve problem B on your own, and then continue watching to see if you got it right. That's the best way to learn something. So n minus 4 greater than 3, okay? So for the positive domain, n minus 4 is greater than 3 and is greater than 7. For the negative domain, all I did is I just added plus 4 on both sides, okay? Negative n minus 4 greater than 3. So I have to get rid of the negative, so I can divide or multiply by a negative. It will give me negative n minus 4 less than negative 3. Add plus 4 on both sides, right? Which would give me n is less than 1, right? right? If I add plus 4 on both sides, that will be n is less than 1. In other words, uh, n is greater than 7, okay? N is greater than 7 and it's less than 1. Does that make sense? And that's it. And first problem asks you, which of the following numbers shown in the answer choice is not a solution to the inequality? The best way to do this sort of problem or any inequality problem is simplify the expression. So we have 3 minus n less than negative 2. We have 2n plus 3 less than or equal to negative 1. Okay? So let's solve the first problem. So we have 3 minus n less than negative 2. So we can subtract negative 3 on both sides, which would give you a negative 5. When you have negative on both sides, you don't have to change the sign of the inequality and retain it as it is. Just simply cancel out the negative. So n is less than 5. We have 2n plus 3 less than or equal to negative 1. We have 2n is less than or equal to negative 4. All I did is I subtracted negative 3 on both sides. So n is less than or equal to negative 2, right? That is, I divided by 2 on both sides, right? So n is less than 5 means n can have values of 4, 3, 2, etc., all the way to negative infinity. N is less than or equal to negative 2 means n can have values of negative 1. I mean, n can have negative 2, negative 1, 0, sorry, negative 2, negative 3, negative 4, negative 5, negative 6, so on, right? So which of the following is not a solution? Well, look for values that are present in both of these, okay? So n cannot even have a value of 5. That means n cannot have a value of 6 for sure. N can have 2, so possible. N can have negative 2, possible. Negative 5, which means negative 6 is possible. 6 is the only one not possible. The highest number we can have in the positive domain is 4. So 6 is out of question. So that is the correct answer. Okay. Problem 2 is opposite to problem 1. In problem 1, we studied which of the following is not a solution to the inequality. Here you have to figure out what is a solution to the inequality. So, but the idea of solving is essentially the same. So you have 5w plus 7 greater than 2, and you have 6w minus 15 less than or equal to 3 times negative 1 plus w. So for the first part, let's just subtract negative 7 on both sides, which would make it negative 5. So w is greater than negative 1. What does that mean is w can be 0, right? Can be 1, 2, 3, 4, and so on, right? Right. Similarly, you have to solve for this one. So you have 6w minus 15 less than or equal to minus 3 plus 3w, right? I just multiplied the 3 into this expression here. So if I add negative 3w on both sides, which would make it 3w minus 15. Okay, I just added negative 3w on both sides, which would make it minus 3. And then I had plus 15 on both sides, which would make it 3w less than or equal to 12. W is less than or equal to 4, right? W less than 4 means W can be 4, 3, 2, 1, 0, so on, right? So W cannot have a negative value, period, right? So it's not possible. W cannot have 5 or 8 because, I mean, W can have 5 or 6 or 7 here, but W fails here, right? W here can only have a maximum of 4, right? 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 It has to work for both expressions, right? So 5 and 8 are out of question, right? Why? Because W, maximum W can have is 4, okay? In one case. In the other case, W can be a lot of values, but when you when you when you want a value that satisfies a solution to both the expressions, then you have to combine, which means you chop it off for 4 here. So 5 and 8 are out of question, which means W is either 0 to 4 or 4 and below, right? So even -1 is not possible, right? Because -1 is possible here, but it's not possible here because W is greater than -1, right? So that means -1 is not possible either. So it's only 4 to 0 is possible in both cases, which means only one of these can be the answer and only one value appears in both cases, and that's 2. Does that make sense? I know it's a little tricky, even I got lapsed for just a few seconds because you have to think along those lines. It's not a simple solving for, and you can say, oh, I can have infinite values. No, both expressions must merge on some common values where it can provide a solution to the inequality, right? You see how I eliminated where my values fall apart, and then I created a narrow pack of range of values. And then from there, I picked one value, right? Only 2 satisfied those cases, right? Very good. Let's proceed. So I've already told you a dotted line means it includes greater than or equal to or less than or equal to. Okay, an open means I just call it 1. Open means it's just greater or less than 1. Just for instance, I just gave a numerical value. Okay. So let's simplify each of these expressions first before we can figure out which of these graphs would work. So you have -x less than or equal to 5. So if you divide or multiply by negative on both sides, then x is greater than or equal to -5, which means for sure you should have a solid dot, right? So the ones with the empty dot is out of question for sure. This one only contains an open dot, so that's never going to be the answer. The remaining all contain a solid dot, so we are not still out of the waters yet. So let's keep this for time being. Let's go to the second expression. So we have 7 minus 1/2 x greater than x plus 1, right? So let's simplify this further. So let's take the half x to the other side, which means it's x plus 1/2 x plus 1, then you have 7 greater than this, right? So we have 7 greater than 3x over 2 plus 1. Now let's subtract 1 on both sides, which is 6 greater than 3x over 2. We can divide by 3 on both sides, which would make it 2 greater than x over 2, right? Divide by 3 on both sides. Now multiply by 2 on both sides, so 4 greater than x, right? In other words, x is less than 4, right? 4 is greater than x is same as x less than 4, right? So now you know these two expressions. X is greater than or equal to -5, and x is less than 4. Greater than or equal to -5, what does that mean? You can have -5, -4, -3, so on. X less than 4 means you can have 3, 2, 1, etc., right? So which of these 3 expression captures both the sense? So x is less than -5. This is a likely candidate, right? X is less than -5, which means it captures -5, -4, -3, -2, -1, 3, 2, 1, and then, well, actually let's this also contains 0, -1, -2, and so on, right? So the best way to do it would be actually write it in this format. So we have x is greater than or equal to -5, and it's less than 4, right? So it can only contain value within this expression. While it seems like this is correct, okay, why does it fail? Think about it. This is going to infinity, right? This is going to positive infinity. It seems like this captures this 3 to 1, right? But it's going on to infinity. No, but our maximum x can have is 4, right? That means you have a combination of a solid dot and an open dot, right? So that means this is also out of question. We can have this, but then this is incorrect. Why is this incorrect? Because this is not capturing a collective expression. You have a collective expression. These are two separate expressions, so that's out of question, which leaves you with just this. You see, this captures -5, -4, 3, 2, 1, 0, 1, 2, 3. And that's it. It ends at 4. And it also works with the idea that you have a solid dot and an open dot. Open dot is for less than or greater, and solid dot is for less than equal to or greater than equal to. It works in every case, so this is the correct answer. Now, you have to invest this sort of time if you're going to have to get this problem right. Maybe with more and more practice. Now, if I were to do this problem myself for a test, I'm not teaching anybody, so I'm going to be doing it super fast. Now, I can use that speed when I'm teaching you, because then you would simply not be able to follow me as I'm solving the problem, right? It will be so fast. So you can divide the time I'm taking you to teach into at least half or 3 times the time it will take me less to solve the problem, right? So just like that, if you keep practicing, you're also going to see an improvement in how much longer you take to solve the problem. All right, so here's how you do problem 4. So you have -2 less than n less than -1. What's the value of 7 plus 1 over n rounded to the nearest whole number? When you have this expression, that means n can have value of, well, just n is less than -1, n is great, so n can only have value of -1.5 at best. Of course, you can have -1.6, -1.4. I'm just picking -1.5 as one of the values, okay? So 7 plus 1/2 over n would be 7 plus 1/2 times -1.5. So that would be, what is it? It's 14 minus 1.5 over 2, right? So that'll be, you're welcome to use calculator for this section. So you have nothing to lose. So you have 6.25. It's asking nearest whole number for 6.25 would be 6. So 6 is the correct answer. Which of the following is not a solution to the inequality? We have done a problem in this same video where we figured out which of the following number is not a solution to an inequality. So I highly recommend you pause the video, figure it out, and then continue watching to see if you got it right. So we have 1/2 x minus 1 for the positive domain, because it's an absolute, is less than or equal to 1. So if you add 1 on both sides, it's 1/2 x less than or equal to 2. You can multiply by 2 on both sides, which would make it x less than or equal to 4. And that's one end of it. So the negative domain would be -1/2 x minus 1 less than or equal to 1. You can multiply or divide by negative throughout the expression, which would result in flipping the sign of the inequality. So you add +1 to both sides. So 1/2 x is greater than or equal to 0. So you can multiply by 2 on both sides. So x is greater than or equal to 0, right? So x is greater than or equal to 0 and is less than or equal to 4. So x can only have values of 1, 2, and 3, right? X can have 0, x can also have 4, right? So which of the following is not a solution? We can have 0, we can have 2, we can have 4. We can have 1 and 3, but that's not listed in the choice. 6 is the only one that we can have, and that is the correct answer. Okay. So we are given the graph and we have to figure out the inequality. So we have one dot, solid dot, and one empty dot. So which means, well, it's still not easy to eliminate at this point, but let's tackle one side at a time. In here, our value is going up all the way to infinity, right? So that means x is greater than or equal to 4, right? Remember, I also mentioned because these two terms are separate, they're not together. It's not like the dot and the solid dot and the open dot are connected like we did earlier. If that's the case, then you have a range of an expression. Here, these two should just be apart. So in that perspective, you can eliminate C and D. You only have to be A or B. We now know x is greater than or equal to 4. Clearly, this is incorrect. So it can only be A. So you can also use a process of elimination, but let's actually properly complete the problem. Here, x is less than -2, and that also works. Okay. What is the greatest possible value of x? Again, you have to simplify the inequality first before you can really do much with it. So let's add x on both sides, okay, which would get rid of the negative x. Let's add 1 on both sides, so that'll get rid of the -1. Now let's simplify this further. So it's 5x over 4 less than or equal to 6. Now we can divide by, I guess we can divide by 5, which would make it x over 4 less than or equal to 6 divided by 5. Now we can multiply by 4. Here I'm dividing by 5, by the way. Here I'm multiplying by 4, which would make it x less than or equal to 24 over 5, right? 24 by 5 is 4.8. So x is less than or equal to 4.8. What is the greatest possible value of x? Well, it's less than or equal to 4.8, right? So that means you can, if you round it off to the nearest, you can't go above than 4.8. So you can just leave it as it is, okay? You can have the greatest possible value x can have is 24 over 5 or 4.8, okay? You can round it off to a 5 because 5 is not 4.8 because we also have an equal symbol, right? So x can be 24 over 5 or can be written in fraction as 4.8. Please also don't round it off to 4. Then that also beats the purpose. X can be 4.8. It is 4.8. Okay, so that's the maximum value x can have. If it asks for a minimum value, then it's negative infinity. Okay, x can be negative infinity. So if n is an integer, what is one possible value of n? So let's go ahead and solve it. So we have an absolute value of 3 over 4n minus 2 less than 1. So for a positive domain, we have 3 over 4n minus 2 less than 1. So let's add plus 2 on both sides. So that's 3. So we can divide by 3 on both sides, which would make it n over 4 less than 1, right? You divide by 3 on both sides. And then we can multiply by 4 on both sides, which is 4n n less than 4, right? That's positive domain. So for the negative domain, we do the same. So 3 over 4n minus 2, you have a negative sign less than 1. If you multiply or divide by negative, then you get 3 over 4n minus 2 is greater than negative 1. 3 over 4n greater than 1, right? So again, you do the same. You can divide by 3 and multiply by 4, right? Which is n greater than, you're multiplying by 4, divide by 3. So n is greater than 4 over 3. So n can be either less than 4 or n can be greater than 4 over 3. It's only asking one possible value, right? So what's 4 over 3? 1.3. So let's say n is greater than 4.3, right? So n is greater than 1.3. So let's say n equals 2, and n is less than 4, n equals 3, 2, 1, so on. So in both cases, 2 is a likely candidate, right? I mean, in this case, you can have 3 as well, then 3 is possible. But I don't think you can go any further than that, because then this expression fails. If you go to 4 here n fails. So you can have 2 or 3. 2 is likely a value, 3 is likely a value. This is an open-ended problem. So 2 or 3 could be a correct answer. Okay. You can have 0 because here n is greater than 1.3. So 2 or 3 for time being. Okay. Thank you for watching. I'll see you with another video on inequalities and graphs. So continue watching my channel. Thank you for your support. I'll see you soon. Bye-bye.